Good morning. Before we study the kinetics and the mechanism of free radical addition polymerization, let us first study about addition polymerization. What is called addition polymerization reaction? For example, ethylene molecule undergoes polymerization in the presence of initiator to give polyethylene. Similarly, vinyl chloride undergoes polymerization to give polyvinyl chloride PVC. Also, styrene molecules undergoes polymerization to give polystyrene. So, in addition polymerization, the monomer molecules are simply added together to form a linear chain polymer product without the formation of any byproducts. Whereas in condensation polymerization reaction, there is formation of simple byproducts such as water molecules, ammonia, ethanol. They are removed during the polymerization reaction. In addition polymerization reaction, the molecular mass of polymer is simply the multiples of molecular mass of monomer. Okay, where Mp is the molar mass of polymer, where Mm is the molar mass of monomer. There are three types of addition polymerization reactions depending upon the types of reaction intermediates. For example, during addition polymerization reaction, there are three reaction intermediates formed. They are free radical intermediate, cationic intermediate, and anionic intermediates. So, based on the reaction intermediates, there are three types of addition polymerization reactions. They are free radical addition polymerization reaction, ionic addition polymerization reaction. Under ionic, there are two types, cationic addition polymerization or anionic addition polymerization reactions. If the addition polymerization reaction is induced by or initiated by free radicals, then the addition polymerization reaction is called free radical addition polymerization reaction. The free radicals are generated by using initiators as we see. What are called initiators? Initiators are used in free radical addition polymerization reactions to produce or to generate free radicals. For example, 2,2 prime bis isobutyl nitrile and benzoyl peroxide or lauryl peroxide, they are used as initiators. The free radicals are generated either by thermal decomposition or photochemical decomposition. For example, in this case, these two free radicals are produced. In benzoyl peroxide, phenyl free radicals are produced. These free radicals are unstable species. Please remember, these free radicals are unstable species, neutral species with unshared or unpaired electrons. Therefore, they are paramagnetic in nature. Let us now study the reaction mechanism of free radical addition polymerization reaction. The free radical addition polymerization reaction mechanism involves three steps. There are three steps involved in free radical mechanism. One, chain initiation. 2. Chain propagation. 3. Chain termination. We will first study chain termination, initiation. In chain initiation step, the free radicals generated or obtained from the initiator reacts with the monomer molecule to form monomer radical. To form monomer radical, it is called RM or M1 dot or M1 dot, or generally we call M dot. In chain propagation step, the monomer radical further reacts with the second molecule, to give or M2 dot or M2 dot or simply M dot. This further reacts with another monomer molecule to give RM3 dot M3 dot, and this further reacts to give Mn dot or Mn dot. The third important step in free radical mechanism is chain termination. There are three ways chain reaction can be terminated. One, radical coupling or radical combination. 2, disproportionation reaction. 3, chain transfer reaction. In radical coupling or combination reaction, the polymer radical, the two polymer radicals couples or combine to give a neutral molecule. Okay. In disproportionation termination step, the two polymer chain radicals undergoes disproportionation reaction to give stable products. For example, here one of the hydrogen here, in disproportionation reaction, one of the atom is migrated or is shifted to here. This hydrogen is transferred to here. Therefore, RCH2 and RCH2CH3 products are formed. These are intrinsic mechanism. Whereas in chain transfer, thiols or similar compounds are added to terminate the addition polymerization. For example, the polymer chain radical transfers its radical to thiol to give thiol radical and a stable polymer molecule or CH2CH3.
We have earlier seen the addition polymerization. What is addition polymerization? What are initiators? What is the mechanism of now we will derive the kinetic rate equation for the polymerization. There are 4 steps involved in free radical addition polymerization reaction. They are free radical formation. The first step is free radical polymerization. The second step is chain initiation and chain propagation, third step, and chain termination. Okay. Now let us write the mechanism and the corresponding rates. In the first step, the free radicals are generated from the decomposition of initiator. Therefore, the rate of decomposition of initiator is equal to Kd into concentration of I, where Kd is the rate constant for the decomposition process. Okay, now free radical radicals are produced, the rate of radical generation, the rate of radical generation for each initiator molecule. For each initiator molecule, there are 2 free radicals generated. Therefore, the rate of radical formation is equal to twice the rate of RD. Therefore, 2 into Kd concentration of I. Now, let us see initiation step. The free radicals formed induces the addition polymerization reaction. It initiates, therefore, R dot plus R dot, the free radical reacts with the monomer to give R M1 dot, M1 dot or M1 dot. Therefore, the rate of initiation is equal to Ki concentration of R dot M, concentration of M, where Ka is the rate constant of initiation process. Now let us study the chain propagation step. This is very, very important. Okay. Here M1, the monomer radical reacts or combines with another monomer to give M2 dot, and again M2 dot will react with another monomer molecule to give M3 dot, and so on to give Mn dot. Okay. Therefore, the overall rate of polymerization, is equal to concentration of Kp into concentration of M dot. M1 dot, it is generally represented as M1 dot, M2 dot, M dot. Okay, M dot constant and into concentration of monomer. Okay, this is the rate of propagation step. Now let us see the termination step. Termination step, we have earlier studied. There are 3 ways the polymerization reaction can be terminated. For now, there are 2 intrinsic mechanisms. Since we don't add the external terminators. Okay, now the 2 monomer radical, the 2 polymer radical couples to form stable species, stable compound. Okay, therefore the rate of this radical combination is equal to Kt concentration of M dot square. Similarly, the two radicals react to undergo disproportionation to terminate the reaction. Therefore, the rate of termination through disproportionation is equal to again Kt concentration of M dot square. Therefore, the rate of termination is equal to twice Kt concentration of M dot whole square. Okay. Now, from the reaction mechanism, the rate of initiation is equal to rate of radical formation, because the free radical addition reaction is initiated by the free radicals formed. Therefore, the rate of initiation is equal to rate of free radical generated or formed. Therefore, Ri equal to, this is Ri Ka R dot concentration of M equal to 2 Kd concentration of I. Okay. By applying steady state approximation, the intermediate species in the free radical addition polymerization reaction, the intermediate formed is polymer radical. They are highly unstable. Applying steady state approximation, the rate of initiation is equal to rate of termination. Therefore, since R radical is involved, we use this one. This is Ri equal to Rr. Therefore, Rr 2F Kb concentration of I equal to, the concentration of radical is difficult to determine, whereas the concentration of initiator is known. We have taken known concentration of initiator, therefore equal to 2 into termination 2 Kt concentration of M dot whole square. Now, what is F? F is F equal to 1 for 100% efficiency. For example, if all the free radicals generated initiates the free radical addition reaction, then F equal to 1. That is, fraction of radicals. F, what is F? F is the fraction of radicals that initiates the chain reaction, chain polymerization reaction. It is less than 1 or equal to 1. Okay. Now let us now consider F equal to 1. Now from this the concentration of radical is determined by using steady state approximation. The overall rate of the reaction, is equal to rate of initiation and the rate of propagation. The overall rate of reaction is equal to rate of initiation plus rate of the sum of rate of initiation and the rate of propagation reactions. But for one initiation step, there are 1 lakh, n may be 1 lakh or 2 lakh. There are 1 lakh propagation step. Therefore, the rate of propagation is much greater than rate of initiation reaction. Therefore, the rate of overall reaction is considered to be equal to rate of propagation. Therefore, Kp, this is Kp, m dot, we have obtained this, you substitute here, and then concentration of m. Okay. Therefore, the rate of polymerization, free radical polymerization reaction is first order, is directly proportional to the rate of polymerization reaction is directly proportional to the monomer concentration. Therefore, first order with respect to monomer concentration and 0.5 order with respect to initiator concentration. Therefore, we know how much monomer you have taken, how much initiator you have taken. Therefore, these are all constant. The rate of propagation can be the rate of reaction, overall rate of reaction can be calculated. Many problems were asked based on this. Let us now study another important chain length. What is the chain length? Kinetic chain length. Or it is equal to x, it is represented by xn bar equal to number average degree of polymerization. Or xn bar is nothing but degree of polymerization. Okay, it is defined as the average number of monomer that reacts with how many monomer molecule reacts with the R dot. How many? This R dot. How many average number of monomer reacts with the R dot from initiation to termination. That gives the chain length. It is also defined as the average number of monomer per polymer chain or per present in polymer chain. Okay. So it determines the chain length. Okay, it determines the chain length. Xn bar determines the chain length of the polymer. Okay, now how it is determined? It is determined from the ratio of rate of propagation to the rate of termination. Since rate of termination is equal to rate of initiation, it can also be rate of propagation divided by rate of time. But we use this rate of propagation. You know that this is rate of propagation Kp m dot concentration of m divided by and RT. Okay, let us use the termination step because it will get cancelled. And then m dot we have already obtained, derived this. You substitute here on simplification, you will get this. This equation is used to calculate the chain length, kinetic chain length or degree of polymerization. Every year they ask question based on free radical addition polymerization reaction. For example, the degree of polymerization is directly proportional to m and inversely proportional to square root of initiator concentration. They in CSIR gate they will give Kp, Kd. They will ask to calculate the degree of polymerization or kinetic chain length. Okay, so you please understand so that you can solve any problems they ask. Thank you for watching.